So this first question, we've got a spanner that's 300 millimeters long and we're applying a force of 150 newtons, and we're asked to find the torque. Now torque equals force times distance. Now we've got the force, which is 150 newtons. The distance we need to convert into meters. At the moment it's 300 millimeters, so meters, that's 300 times 10 to the minus 3 meters, because milli is minus 3. So our torque is our force, which is 150, times our distance, which is 300, times 10 to minus 3. Now when we put that in the calculator, it's 150 times 300, and this times 10 to the, at the bottom there, minus 3, which gives me 45 Newton meters. Second question, we've got a force of 33 newtons that's applied to a load, and we're moving it 3.5 meters. So the work done is force times distance. Now we've got the force there, 33 newtons, and we're going to move that force. It's going to move the object 3.5 meters. So we're already in meters there. So the work equals the force 33 times 3.5, which is, this answer is going to be in joules. Our work is in joules, 115.5 joules. The next question, we've got a motor, electric motor that has a mass of 100 kilograms. Now, whenever you see kilograms, when we're going to work out the work done, we need to convert that into newtons. And kilograms times 9.81, which is the acceleration due to gravity, and that's a fixed number, 9.81, will give us the force. So our force in newtons is 100 times 9.81, which equals 981 newtons. Now we're going to lift that 12 meters. So it's our same formula, force times distance. The force is 981 and the distance is 12. So we're going to have 981 times 12 equals 11772 joules. Now we can press engineering and we can get 11.7, I'm going to go to 2 decimal places, kilojoules. 11.77 kilojoules. This next one is a crowbar, so it's a lever calculation. We've got the motor there at 400 newtons, so it's already in newtons. If it had been in kilograms, we would have had to times it by 9.81, but that's done for us. And that's 60 mil from the fulcrum. There's our fulcrum there of the crowbar, and we've got 800 millimeters there. How much force do we have to put in there? Well, what we've got on this side, the torque on this side is going to be equal to the torque on this side. So we've got F1 times D1 is F2 times D2. We know F1 and D1. There's F1, there's D1, and we've also got D2 on this side. So if we want to find F2, which is this one here, F2 is going to be this times this divided by this D2. So F1 times D1 divided by D2 will give us F2. Because we're going to take this to the other side, and because it's times in on this side, when we take it to the other side it becomes divide. So we get F1, which is 400, times D1, which is 60, divided by D2, which is 800, and that will give me 400 times 60 divided by 800 gives me 30 newtons. So putting 30 newtons of force here over 800 millimeters will lift this 400 Newton motor. We've got some pulleys in this one. So we've got this pulley of 150 millimeters diameter, and it's spinning at 1500 RPM. And we're going to see how fast the pulley on this side that's got 400 millimeters. Now hopefully you can see if one revolution of this is not going to go a full revolution. So we're expecting this RPM to be less. Now it's the same sort of thing as the levers. If we draw a line down the middle, it's the two that we know on this side times together divided by the one we know on this side. So the speed 1 times the diameter 1 divided by diameter 2 will give us the speed of that second one. So N1 is 1500 times 150 divided by 400 gives me 1500 times 150 divided by 400 gives me 562.5 RPM. So about a third of this, and you can see this is about 3 times, just under 3 times bigger than this, so that works out fine. 400 times this is the same as 150 times 1500. Another one here where we're going to work out the work done and the old force times distance. Now we're told that we've got 20,000 litres of water, and we're told that 1 litre of water is 1 kilogram. So instead of writing 20,000 litres there, we can write 20,000 kg. And we know that the force of 20,000 kg, if we want to find it in newtons, we have to times it by 9.81. So we do that one on the calculator. 20,000 times 9.81 gives me 196200 newtons, and we're going to lift that 6 meters. So work equals force times distance, and my force is 196200 times my distance, which is 6, so I can times this by 6, and that gives me 1177,200 joules. If I press engineering, it gives me 1.1772, and now it's times 10 to the 6, so it's mega joules. Just over 1 megajoule of work, of energy. This one is looking at the power produced by a motor, and we're going to find the torque. Now we've got the formula for power there, and what we're going to do is transpose that to give torque. It's given here, but I'll show you how to do it. We've got power equals 2 pi nt over 60. To get the t on its own, we're going to get rid of this 60, going to take it to the other side, and so it's dividing here, so it becomes times. So it becomes p times 60 equals 2 pi nt. And now we're going to get rid of this 2 pi n, because then that will leave us the formula for t. So it's all times in there, it's times by that t, so we're going to take it to the other side and we're going to divide. So torque is equal to the power times 60 divided by 2 times pi times n. Now when we put this in the calculator, we need to put this in brackets. So we've got the power, which is 10 kilowatts, so it's 10,000 watts, times 60 divided by 2 times pi times the speed, 1475 in this case. So that's 10,000 times 60, I'm going to press equals there, divided by, open brackets, 2 times pi times 1475, close brackets, equals, gives me 64.74, and we're looking for torque, so it's Newton meters. One just below is about efficiency. So we've got our motor, we put a certain amount of power in, which is in this case 8.9 kilowatts, and the mechanical power that we get out is 7. So the efficiency is output over input times 100%. So we get 7 out, we put 8.9 in, times 100, 7 divided by 8.9 times 100, gives me 78.65%. Last one is the gears. So this is similar to the pulley and to the levers. We draw a line down the middle, 2 that we know on this side times together divided by this one. So we've got N1 times, we're going to call it teeth 1 is equal to N2 times teeth 2. So we want to find N2, so we're going to take this to the other side and divide. And that's going to be 1500 times 65 divided by 25. 1500 times 65 divided by 25 gives me 3,900 RPM.